Hi. In today's video, we're going to talk about factoring, which is the word we use to help us solve quadratic equations. So in the last video, we talked about how it was possible that we could solve quadratic equations. In this video, we're going to introduce factoring, which is our primary method of solving quadratic equations. So what is factoring? Well, let me start with an example problem that illustrates why factoring is useful in the first place. All right, say we're asked to solve the quadratic equation x minus 1 times x plus 3 equals 0. And at first glance, you might say, well, that looks nothing like a quadratic. I don't think this is a quadratic. Well, it actually is if I use the distributive property. All right, so x times x, that's x squared. X times 3, that's 3x. Negative 1 times x, that's negative x. Negative 1 times 3, that's negative 3. And that's x squared plus 2x minus 3, which is indeed a quadratic. So we know that this then has to represent a quadratic. So we can get that worry out of the way. But how does this form help us solve quadratics? Well, notice this whole thing is equal to 0. So if any x value makes either x minus 1 or x plus 3 equal to 0, when I multiply those two things together, my answer will be 0, because anything times 0 is 0, right? So x minus 1 can be 0, or x plus 3 can be 0. And if I solve that to get x by itself, I have x equals 1 and x equals negative 3. So if I put x equals 1 or x equals negative 3 into the equation, I will get 0 equals 0. So they're both solutions. They're both answers to the equation. Let's do another couple. Let's say I have x plus 5 times x plus 7 equals 0. I can have x plus 5 equals 0 as a solution, or x plus 7 equals 0 as a solution. Isolating x, I get x equals negative 5 and x equals negative 7. So these are both solutions to this equation. We can do some more. We can say 2x minus 1 and 4x minus 3 equals 0. So that means 2x minus 1 can equal 0, and 4x minus 3 can equal 0. If I solve for x, I get 2x equals 1, x equals 1/2 on this side, and 4x equals 3, and x equals 3/4 on this side. They're both solutions to my equation. And now you see the real value of putting quadratics in factored form. This is factored form. It allows us to set each of the factors equal to 0, solve like we would solve a linear algebraic equation, right? This is basically a multi-step equation. This is a single-step equation, like we've been doing all along, and find our values. So factoring makes our job a whole lot easier. It takes a quadratic and basically splits it into linear equations that we already know how to solve, that we've already practiced solving. And this is why factoring is so valuable. We're just basically taking what we learned earlier and applying it to this new subject here. So now we know what to do if we do get a quadratic in factored form. If I get a quadratic in factored form like this, I set both of my factors, the things in parentheses, equal to 0, and I solve for x. And the x values that I get, both of them, will be my solutions. But what if I have a problem? How do I factor on my own? How do I take a quadratic that isn't in factored form and put it into factored form? Right. So I have x squared minus 3x minus 10. Well, how do I put that into factored form? Good question. So we want to put it into factored form so that we have x plus a times x plus b equals 0. That's factored form. But how do we put that in factored form? Well, I know my two numbers, a and b, have to be multiplied together to get negative 10. Right? But I also know if I were to distribute this out, I would have x squared plus ax plus bx plus ab. I know that these two numbers have to add together to equal negative 3. This is true for every quadratic. They have to multiply together to get this, and add together to get this. What two numbers multiply together to get 10? Well, I know if I multiply, let's say, 5, actually, hold on, 2 and negative 5, right? I multiply 2 by negative 5, I'll get negative 10. And if I add 2 and negative 5, I'll get negative 3. So I have to have a be 2 and b be negative 5. And so my factor form is x equals 2, x equals negative 5. Then we would go from here and say x plus 2 equals 0, x minus 5 equals 0, solve for x equals negative 2, and 5. And those are our solutions to our equations. As a general rule, if we were to go back to standard form, x squared plus bx plus c equals 0, ax squared, the first thing we want to do to transform this into factored form is get rid of the a, right? I'm going to divide out by a if I have an a that's not 1. So I try to divide this whole thing by a and get that out. But for the sake of simplicity, let's say we don't have an a, right? We just have x squared plus something times x plus something else. How do we transform that into factored form? Well, I'm going to call them c and d just to actually d and e just to avoid repetition. This is factored form. Well, I know that d times e has to equal c, and d plus e has to equal b. So basically, my two numbers that I'm adding to x in my factored form have to multiply to be my number, and have to add to be the coefficient next to my x. Right? Let's do some practice with this. Let's say it's something like this. X squared minus 11x plus 28 equals 0. I want to factor this, right? So I know that my factored form is going to have two numbers that multiply together to get 28, but add together to get negative 11. What numbers do that? Well, let's think about the factors of 28. I can have 7 times 4. And I notice, hey, wait a minute. If I have negative 7 and negative 4, I add them together, I'll get negative 11. And if I multiply them together, the two negatives will cancel out, and I'll get 28. So my two numbers have to be negative 7 and negative 4. So I have x minus 7 times x minus 4 equals 0. And if we wanted to check our work and make sure we factored correctly, we can always do the distributive property. X squared minus 4x minus 7x plus 28. Combine those two together, that's negative 11x. So when we factor, we distribute out, we do get the same thing as we started with, which means we factored correctly. Now, we split this into two linear equations. X minus 7 equals 0, and x minus 4 equals 0. So we have x equals 7 and x equals 4. And those are our solutions. So, this has been an intro to factoring. We're going to go over a lot more different types of harder things to factor and a lot more strategies, just like we did for linear equations, to factor. Right, we're going to go over a bunch of methods and strategies and tips to make factoring easier, even for the most difficult, messy quadratics. That's what we're going to do in the next couple videos. But so far, just to remember, we have this thing called factoring. It takes a quadratic, basically turns it into two multiplied linear equations. We can set those equal to 0, find our solutions, and we solve our problem. So that's why factoring is so valuable, because we can take a quadratic and turn it into linear equations, which we've been dealing with all before. Right? So that's it. I hope this helped, and I hope you have a great day.